Anyway, this is what we did last week. So, it's coming up with the total number of possible outcomes. These are deciding whether it's permutation or combination. So the first one, you've got 27 people and you're picking 3 to go to a trivia game. So is everybody doing the same thing or different things? Same. So that's a C. And bigger number goes first. Just got to use this calculator thingy. And there are 2,925 different possible groups that you could send to the trivia game. A company must hire an assistant, an accountant, and a vice president from 16 applicants. How many ways can they fill the position? So same jobs or different jobs? Different. So P. 16 and 3. 16. 3,360 different possible job combinations. Okay, so that was last week. Today, we're doing probability, and that requires knowing what a sample space is. So where these were to find the total number of possible outcomes, the sample space is the actual possible outcomes. So some sort of list or representation of all possible outcomes. So obviously, if I were asking for a sample space, I would try not to ask for anything where you had to write 3,360 different possibilities, but the sample space would be all of the things that could possibly happen. So with this one, rolling a die and flipping a coin, I think the easiest way to do these is to make, it's called an area model, but I just think it's like a table. So you've got 6 spots for the die, and then heads or tails. So literally it's it can be tedious, but it's literally just writing out what are all the different possible things that could happen. Okay. That would be the sample space of those actions. Anyway. Okay. So theoretical probability. Basically, when we say theoretical, it just means knowing what we know about it. What are the chances of it happening theoretically? It doesn't mean it'll always work out exactly that way. But there's something called, what is it, the law of large numbers. And basically, if you repeat something over and over and over again, your data will start to look like what should theoretically happen. It's just, there could be a fluke, where I was playing a board game with my friend for her birthday. We had a game night, and it was dice, and we kept rolling 11s, which statistically, you're not, probability-wise, you don't have a very good chance of getting 11, but we kept doing, anyway. That's beside the point. I'm rambling. So that's the notation. That just means the probability of whatever A is happening. And it is number of ways A could occur, or number of times A could occur, over the number of total possible outcomes. So that's why the number of total outcomes is important, because that's the denominator. And that's probability. I mean, that's just is what it is. So if you have a jar with balls in it, 3 red, 5 yellow, 7 purple, The probability of getting red is going to be 3 over the total, which is 12. Now, probability can be written as a fraction, a decimal, or a percent. And the most common way that it's used in math is with a percent. A decimal one. So we're going to use a decimal. So, oh wait, did I add it? It's 15, not 12. Sorry. So 3 out of 15 is 0.2, which is basically 20%. There's a 20% chance of getting a red one. If it says purple or yellow, well, you just add them together. There are 12 balls that are purple or yellow. So 12 over 15, which is 0.8 or 80%. Cool? Awesome. Yeah, I mean, simple probability is not too crazy. All right. So rolling a six-sided die. How many 2s are on a six-sided die? 1. So it's 1 out of 6, which is 0.17. How many even numbers? 3 out of 6. How many numbers are less than 5? 4. And how many numbers are 1 or 6? 2. So literally it's just how many over how many. Now, the only time it gets a little bit weird is when you have this, because sometimes like there's 2 qualifiers or whatever. Like there's a term called mutually exclusive, and we'll talk really more about that later. But basically, they're telling me that I have 12 shirts and some are blue and some are green, and some of them fit and some of them are too big. So the easiest way to do this is to actually write out the sample space, because otherwise it gets like confusing. So I've got 6 blue and 6 green, so I'm just going to go ahead and write 6 blue, B for blue and G for green. And then 2 of the blue shirts and 4 of the green shirts fit well. So I'll just put little 2, 3, 4. Little F's for fits. And the rest are too big. So those are too big. What is the probability of getting a shirt that is blue or too big? So that would be all of these guys, which is 1, 2, 3, 4, 5, 6, 7, 8 out of 12, which is 2 out of 3, which is so about a 67% chance of getting a shirt that is blue or too big. Yeah, if you write it out, it's just easier, because like trying to figure all that out in your head can get like weird and confusing. Oops.